Okay, let's start. Bismillahir Rahmanir Rahim. So in the last class, if you do remember, so we were discussing. We had discussed chapter number 1. In chapter number 1, we had discussed protocol layers and service models, network security, and a little about history of internet. Okay. In today's class, we are going to start a new chapter number 2, from computer networking, a top-down approach, 7th edition. In this class, we are going to study application layer protocols. So we are going to study application layer protocols, network applications, their structure, socket, transport layer services, and web and HTTP protocol. Okay. So let me remind to you that the communication between two users via internet, that is the communication between two internet applications. The communication between two internet applications is a complex process. So how we deal with it? So we deal with it by dividing it into layers. So the internet communication is divided into 5 layers: application layer, transport layer, network layer, data link layer, and physical layer. Okay. How the user use internet? So we have discussed that the user use the internet via applications. So we are discussing how these applications are developed, how these application protocol work. Okay. So let's start chapter number 2, and it is about application layer protocols, and this is from the top-down approach, computer networking, a top-down approach, 7th edition book. So these are the outlines of chapter number 2. So let's start. So there are several network applications. Many of them you have been using. For example, email like Gmail, Yahoo. I think all of you are using email. Second is website access, web server access. All of you are using to access websites like yahoo.com, etc. Many of you are using text messaging via Facebook, Yahoo Messenger, Gmail chat, etc. I think some of you have experienced remote login. For example, you can log into a machine, a server that is in US or in UK or in somewhere else. Similarly, P2P file sharing like uTorrent you are using for sharing files. Internet games, many of you, some of you know about internet applications and how they are used. Similarly, I think most of you know about YouTube and Netflix. These are used for downloading audio video files or watching videos. Skype voice or IP application, real-time video conferencing, social networking application like Facebook, LinkedIn, etc., and Google search engine and other search engines. Okay, so these are the network application. These are the internet application that you are currently using. So in this chapter, we are going to discuss how these applications protocol work, because these are application, and so how their application layer protocol works. So we are going to study the principles, the working, the technicality detail of these applications. Okay. So first of all, when you create any application, for example, when you develop any application, whether it is a desktop application, whether it is a network application, so you must have to develop to write a programs. So the application, what are applications? They are developed by writing program. So when you write a program, and that program becomes applications. Whether you write the program in Java language, in C++ language, or in VB language, or any other tool like Python, etc. Okay, so when you are developing applications, okay, so these applications, they are developed using a particular programming language. So any application, whether it is a desktop, a network application, so they are the written programs. But the desktop application, it runs only on one system. However, the network application or the internet application, they run on different end systems. For example, one application is running here, one application is running here. For example, here Gmail server is running, and here the user is accessing the Gmail server through Internet Explorer. Okay, so these two applications, they are residing on different system, and they are communicating with each other. They exchange messaging with each other. So the network application, they are also programs, but their difference is from the desktop application is that these applications often run on different end system, and they communicate with each other. They exchange messaging with each other. For example, a web server, here it is running Gmail server, suppose Yahoo server, Yahoo web server, Yahoo email server, it is running here, and through web browser, through Internet Explorer, it is a client, the user is accessing this Gmail server. Okay, so normally when, as you know that the internet structure is divided, the internet physically, it consists of three things. The first one is end system, where the application runs, where the users sit and use the internet. The second thing is routers. These forward the message on the best path. This is called cold network. And the third thing is the links that connects to router or one host and router or two hosts. Okay, so the user sits on the end systems to access the internet via application, and so and these router, there the users don't sit here. These devices, they only have three layers, no application layers. So the core devices, they don't run the user applications. Why? Their function is only to forward the data on the best path. Okay, so usually this application, they are developed for end system. The application are developed for end system. The software, the programs are written for end system, not for the network core applications. So application and end system allows for rapid application development and propagation. Okay, so because new and newer and more new and application, they arise. So all those things that you need to implement new things, so you have only to do that implementation on end system without disturbing the routers. Okay, so this is, for example, the two applications, they are communicating with each other, like these two applications. One is running on the mobile phone, this is client, and this is the server. Here this is the desktop, here the client is running, and here is the server. They are talking to each other. Okay, so application to application, they are talking to each other. In the network application, these are the programs that are developed, but these application, their uniqueness is that they exchange with each other the messages. They exchange the messages with each other. Okay, now the application architecture, when two applications talk to each other, the communication between two applications based on the there are two types of communication. So based on the communication between two applications, the network application are divided into two types. One is called client server model and one is called peer-to-peer model. In the client server model, one user is client and the client is one which requests for a service, and the server application is the one which provides their service. For example, you are accessing the Gmail server. Okay, yeah, for example, you are accessing Yahoo web server. So Yahoo web server is a server, and you are accessing through Internet Explorer. For example, you say that I want to access news on the Yahoo web server, so you can get it. Yahoo News or international news or some for example Yahoo email, etc. Okay, so the client server model, one application will be client. The client is one application that requests for service. For example, here you can see it. The client is one that communicates with server. Okay, and it may have intermittent connectivity. For example, you access the web Gmail server, Yahoo email server. So when you log on, when you want, you can access Yahoo server, then you can switch off your mobile phone or you can disconnect from internet. But the Gmail server, it never disconnects. It is always run on host. It's always run on a permanent IP address. It runs 24/7. It doesn't switch off. It doesn't close. It is always running. Why? Because all the people they are accessing. So the user can be intermittent. For example, sometimes user comes to access the Gmail server and sometimes it close its mobile phone, disconnect from the internet. So it is its own choice. But the server, it doesn't have choice. It is always running on a host, and it has permanent IP address. If its IP address change, for example, you are accessing Gmail, so the Gmail address, it doesn't change. Okay, if it change, then you have to then the client will be disturbed. Okay, and the client, they may have dynamic IP address. For example, you are accessing Gmail from university internet, so you will have you are accessing the Gmail server from the university IP address. When you come to home and you access the Gmail server, then you are accessing the Gmail server from your home IP address. So the client IP address, it can change. Okay, and the clients don't communicate directly with each other. There are two clients. For example, this client is accessing server and this client is accessing. They client don't talk with each other. Only they talk to each other. So they are requesting the services from server, whether it's to access a file, whether it's to access image, whether it is to know about something, etc., etc. Okay, so usually the server, the server, it is running on a particular one machine, or it may run on multiple machines. For example, on a data center. Okay, for example, the Gmail, Google server, they are not running on one PC or on one server, but they are running on many servers, many machines in a data center. Okay, because it requires huge bandwidth, it requires huge memory, it requires huge bandwidth. Okay, so the application the application architecture can be divided into client server. So the client server is one where one application is a client that requests for service, and the other application, it provides the service, that is called server. Another architecture, the second architecture, it is called peer-to-peer. In peer-to-peer, an application work both as a client and a server. For example, you may have used uTorrent. On uTorrent, you can access the files from others. You can download the movies from other people's. And when you have downloaded the movies, so you become the seeder. So then you can share your movies with others. So you are accessing, you are downloading the movies from others, and some other people are downloading movies from you. So you are accessing the service, you are requesting the service to, from others, and you are also providing service to others. So you are client and server both. So this is called peer-to-peer architecture. Okay. So the peer-to-peer architecture, it is like this way. There is no server. Okay. So each users, they can, for example, this user can access the file from this user is accessing the file from here, and this user may also provide file to him or to another user. For example, this machine, it is accessing the file from here, downloading the movies from the car, and it also provide another movie to this one. So this laptop is downloading the movie from here. So it is downloading movie from here, and it is downloading movie from here. So here this one is working as a client to download movie from the car, but this is working as a server that provides the movie to the laptop. So this is called peer-to-peer. Okay. So the peer-to-peer architecture, it is arbitrary and system can directly communicate with each other. Okay. So the peers request service from other peers, provide and also provides service to other peers. So this have the scalability. Okay. So we will discuss them in more detail. Okay. So what is the limitation of client server architecture? For example, in Pakistan, suppose this is the Gmail server or YouTube server, and Pakistan blocked this YouTube server. So no one from Pakistan can access the YouTube server. Why? Because the YouTube has a permanent IP address. So the Pakistan will block its IP address. So no one from Pakistan can access the YouTube server. Okay. So the censorship on the client server model is easy, but on the peer-to-peer it is not easy, because if the Pakistan block this machine, this peer, its IP address, okay, but there is another peer that can provide the same file. Okay, so any user can provide the file. Okay, so in the peer-to-peer model, so that's why it is very difficult to block each and every IP address. So that's why it is very scalable. Okay, and here you can see that in client server model, all people, they are accessing Gmail server. If the Gmail server goes down, then no Gmail will be service will be available. But in the peer-to-peer model, if this peer is switched off, but you can access the file from other peers, from these peer, from these peer. Okay, so it provides the scalability. Okay. So we have discussed the architecture, the application architecture. So it can be in application architecture means that how the internet application communicate with each other. So there are two types. One is called client server, one is called peer-to-peer. In client server, one application is always requesting for a service, and another application is providing. In the peer-to-peer, an application is requesting service from others, as well as the application provides service to others. Okay. So now, as we have discussed, if you do remember, so we have discussed that what is a network application. The network application is a programs that are written in a language. Okay, but their difference is that these application, these programs, they exchange, they communicate with other programs that is running on some other end systems. Okay, so when these are programs, so when a program is developed and then the program is executed, when the program is running, then it is called a process. From operating system point of view, when a program is running, when you develop a program and then you start its execution, it's running, then this becomes process, then it is called a process in operating system point of view. Okay, so the process, they can talk with another process that is running on the same host. A process can communicate with another process that is running within same host. This is called inter-process communication. And this inter-process communication within a host, for example, two processes, they are communicating with each other. Two applications that are running on the same host, they are communicating with each other. This can be achieved through operating system inter-process communication. Okay, but when two processes, they want to communicate and they are running on different host and they want to communicate messages, so this cannot be done by inter-process communication that is provided by operating system. For this purpose, we need another API which is called socket. So usually this socket is used to provide communication between two processes, between two applications that are running on different hosts, that are running in different host. So the socket API that is provided by operating system, this API, this library is used for the communication between two processes that are running on different end hosts. Okay, but the socket can also be used for the communication between two processes running on the same host. Okay, but usually it is used for the communication between two processes that are running on different hosts. Okay, so the client server process, the client process is one process that initiate the communication, because the server is always running. So this is the client who has to initiate the communication, and the server process that waits to be connected, so it is always running, so it provides communication. Okay, and the P2P application, it has both client and server process. Okay, because it is also a peer-to-peer in a peer-to-peer architecture. An application is accessing the service from others, as well as it provide the service to others. Okay, like torrent, you can download the file from others, and as well as you can provide files to other groups. Okay, so a socket, it is basically you can see that socket is a library. It is an API that is used by a process to send and receive the messages to and from its socket. So for example, the socket is analogous to a door. For example, sending process shows the message outdoor. For example, this is the sending application, so when it wants to send the message, so it sends the message through the socket, and socket then provides this message to another process, and here from this socket the process can read the received message. Okay, now as you know that these transport layer, network layer, data link layer, these things are implemented. So you can see that the communication between two applications, it is divided into 5 layers: application layer, transport layer, network layer, link layer, and physical layer. What is the role of application layer? The application layer, it interacts with the users. That is, it gets the data from the user in user format and convert it into a system format, and then give it to socket, then give it to transport layer, and the transport layer takes the data from this process and deliver the data to the process, this destination process. When it delivers this data to the destination process, so the application layer gives this received data to the user in the user format. It is received in system format. For example, this is the video sent. Okay, so here this is the application layer to show to user that this is the video, to display the video as a video. So you can see that application layer only interacts with the users, and then when the application layer on the sending side, it takes the data from users and convert it into system format and then give it to transport layer. Now the transport layer has to move the data from source process to destination process. Okay, so here how this data is transferred by the transport layer. Okay, so first how it is done. Okay, so let's discuss it. Okay, so first of all, by sending data from one process to another process, we should have identifiers. For example, I am talking to you. Okay, so if I am talking to you, so first of all I have to, for example, if I want to talk with the Josefa, so I should say Josefa, I am talking to you. Okay, so is your name are used to identify you. So similarly, when the process is, one process is sending data to another process, so there should be identifier to identify that who is talking to who. Okay, so here in the internet we have two types of identifiers. One identifier is called IP address. It is called IP address. So the IP address, it is basically identifying the machine. This machine and this machine. This machine and this machine. So so it is like your home address. Okay. So the IP address, it is used to receive the message, and so the process, they must have identifiers in order to send and receive the messages. Okay, so a host device, a system, it has a unique 32-bit IP address. So whether this IP address is enough, so it is not enough. Why? Because you can see that here in this slide, in this system, it has IP address 1.1.1. Okay, and this system, it has IP address 2.2.2. This system has IP address 3.3.3.3. This system runs application, and its application number is P4. This system is running two applications, P1 and P2, and this system is running one application called P3. When this system sends the data, and if it has only destination IP address, for example, the data has contained IP address 1.1, so the data will be received here. So, and here this data is for which application? So the IP address is not sufficient, because the IP address is used by both applications, P1 and P2. They are both running on this system, and they both have IP address 1.1. So when the data is received on this system and its destination IP address is 1.1, so this IP address is not enough to distinguish that this data is for which application. So for this purpose we use port number. So here the port number is 15 for P1 and port number P2 for 55 for P2. Okay, so here this system, it has port number 55. You can see that this system, this application P3 also has port number 55, and this P2 and the P2, it also have port number 55. So it is not a conflict. Why? Because this port number is used only on this system. For example, this is the office number in Comstate University, office number 3 or room number 202 in Comstate, and this room number 202, it can also be in the Y University. So if you are in the Y, so the room number, it has only scope in the Y University, and this room number has only scope in Comstate University. Similarly, this port number, it is only used on this system, so it is unique only on this system, and it doesn't have conflict on this system, because this port number is used only on this system, so its scope is only on this system, and this port number scope is not on this system. Okay, so let me show you an example. For example, this is a packet, and this packet has source IP address 2.2.2.2 and port number is 55. So this data is from which application? So the application on 2.2, this is the machine. On this machine, the port number 55, it is for the application P3. So this is the data from P3. And this is the destination address. For example, the destination IP address is 1.1. So this is for this machine. So this IP address will be first used to deliver the data from this machine to this machine. So when the data is reached on this machine, now the machine has to identify that this packet is for which application. So they will use the port number. So port number is 15. Port number is 15. So port number 15 on this application, on this machine, port number 15 is used for P1. So this data is for P1. So you can see that an application is uniquely identified by IP address and port number. IP address means on which system the application is running, and on that system on which application is it. So both IP address and port number, they are used to uniquely identify a application. For example, this IP address is 2.2.2, port number 55. So this is this P3 application. Although here the port number 55 is used by P2, but its IP address is 1.1. Its IP address is 1.1. Okay. So this data or this packet is from P3 to P1. Okay. Similarly, suppose this another packet, the red one packet. So its source IP address is 3.3.3. So this is from this machine, and port number is 20. So on this machine, port number 20 is for application P4, and the destination IP address is 1.1.1. So this is for this machine, and on this machine the port number is 55. So this is for on this machine, the port number 55 is associated with the application P2. Okay. So the IP address is not the IP address is not sufficient, because IP address is used for identifying host machine, but on a machine there may be running many applications on the same machine, on the same host. So to identify the application on a host, we use another identifier that is called port number. So both IP address and port number, they uniquely identify a particular application process on host. Okay. Some applications, they are using well-known port number. For example, HTTP server, it is always using port number 80. Whether it is a Gmail, Google web server, it is a Yahoo server, Comset Yahoo server, whatever server is running on any machine, they are using port number 80. But it can run on other machine, but it is convention. For example, when you enter to any office, so there will be a reception. So reception means that this is where you can get information from. Similarly, the email server like Gmail, Yahoo email, Comset's email, CIT email, all the email server, wherever they are running on every machine they are using the port number 25. So a machine or application is uniquely identified by two things: IP address and port number. Okay. So we have discussed it. Okay. So what does a protocol specify? Let me remind you. Okay. As we have discussed that internet is composed of host, routers and devices and links. So these are the machines. So how these machines talk to each other? So these machines communicate with each other by using protocol. Okay. So what is a protocol? So we know that protocol defines the format, the order of message, and when a message is received, what action should be taken. What does that message means? Which type of messages are allowed? Okay, so we have already discussed it in the chapter number 1. So a protocol, like for example, if someone asks you what is time, so you will tell it's 2 o'clock or 3 o'clock. When a person asks you what is time and you say hello, how are you? So it's not the response, it's called incorrect response. Okay. So similarly, the application, when they talk to each others, so they must have to use an application layer protocols. When the application, they talk to each other, so these are machines, the application are running on machines, so the application layer protocol, they have to use application layer protocols. So what a protocol defines? So a protocol defines what kind of messages can be exchanged, like request and response. For example, what kind of messages you can communicate with the director, and when you want to communicate with the director, so you must have to use a proper syntax and semantics. You have to use rules and regulation. So a message, a protocol defines that what kind of messages you can exchange, what kind of communication you can do with the director, what you cannot do, and what should be your message syntax, what should be its semantics. So these are the rules and regulation for when and how process send and respond messages to each other. So the protocol, there are two types. Some are defined using RFC. These are called public protocol, open protocol, and some are called proprietary. Their working is not known. So we have already discussed it. If you do remember, in chapter number 1, we have discussed it, that how RFC is developed. And these protocols are called public protocol. Okay, and some protocol, they are proprietary, their working is not known. These are called, like for example, Skype. Okay, so the HTTP, which is used for website access, it's a public protocol. Its RFC is available, its working detail, each and everything is available. SMTP, it is used for email exchange, and its working is available, it's public protocol. And the Skype protocol is proprietary. The Skype can only talk with the Skype, and you can access from Internet Explorer, Yahoo website, you can access the Google website, you can access the Amazon website, you can access the ComSat website through HTTP protocol. Why? Because it is open, it is interoperability. The Gmail web server, they are the Google web server, they implement their web server by using the HTTP protocol. Similarly, the Yahoo web server, they are implementing their web server by using HTTP protocol. So the Internet Explorer, which is use a client to access the web server, so it is using HTTP protocol. So they are interoperability. Okay, but the Skype cannot talk with the Gmail. Why? Because the Skype is a proprietary. Okay, so there are different types of protocols. Okay, so we have discussed that the internet application, the communication between the internet two internet application, it is a complex process. So it is divided into 5 layers. So the first one is the application layer. The application layer, what is its functionality? It's interaction with the users. For example, it gets the data from the user, and now it gives to transport layer. This is the transport layer functionality, to move the data from this application to another application. Okay, so when you move the data from one application to another application, so the transport layer, what kind of transport layer functionality are available, what kind of transport layer services are available. So let's discuss it. Okay, so the transport layer, it basically moves the data from process to process, from application to application. Okay, so first of all, when the two applications, they sends data to each other, what they need. Okay, so first of all, they need 4 kind of services they may need. One is called data integrity. Some application, they will need that their data should not be lost. Okay, so sometimes some application, when they sense the data, so they will select a transport service which can provide data integrity, which cannot lost the packet, the data. For example, if you are sending the letter, so you can use TCS or you can use Pakistan Post service. Which one is better? So you know it better. Okay, so some application, they wants that there should not be packet loss. The data should be reliably data transferred. The data should be reliably transferred. There should not be even a single bit loss. For example, file transmission. For example, when you download a file and it is executed, so you don't, even if a single bit is lost, you cannot open the file. Similarly, a web transaction, for example, you want to do a transaction, bank transaction, so you don't want to lose a single bit. But there are some applications that can tolerate data loss. For example, audio video communication. If you are talking with each other and some data is lost, so you say, okay, please repeat it again. Okay, or you can from the context you can get the meaning. What does it mean? Or you are watching a cricket match, so you are only concerned that whether the ball, whether there is a 4 or 6 or how many runs are taken on a ball. So you are not concerned that who is sitting in the gallery, etc. So you are only, so if you get that information, like for example, the ball is on the ball, a wicket is taken. Okay, that's good. Okay, so you are not concerned that who is sitting in the gallery, what is around the scene, etc. Okay. Some application, they wants timing. For example, they want that the message should be received within 1 minute or within 1 second. Okay, so it may be a requirement. Some application, they have timing requirement. Some application, they don't have the timing requirement. For example, if you are downloading a file, so if a file is downloaded in 10 seconds or in 15 seconds, it doesn't matter. But if you are watching the movie, or you are watching the news, or you are watching the cricket match, so what is your concern? Your concern is that there should be no pause. There should be no pause. It should be displayed as it is happening. Some application wants minimum throughput. For example, if you are talking audio video communication, so there is need for minimum bandwidth. And some application, they don't require any bandwidth. They are elastic. As much bandwidth as available, that is good. For example, if a file can be downloaded on a 1 MB bandwidth, or a file can be downloaded on 100 MB. Okay, so for example, if you have 1 kilobyte bandwidth, so you cannot watch cricket match live. Okay, or you cannot watch the movies. Okay, but you can download the file, because if on 1 KB it may take 3 hours to download the file. Okay, but if you are watching a live movie, so the low bandwidth will not workable. Okay, similarly, some application, they need security. When the data should be transferred, they should be secure, and some they don't want. Okay, so as I have explained to you, that the transport layer, it transfer the data from application to application, from process to process. So I have explained to you that from application point of view, there can be these requirements. Okay, but now we are going to discuss some applications. We are going to explain through examples some applications. Example, the file transfer application, it cannot tolerate loss. It requires that there should be no loss. Throughput is elastic, means as much bandwidth is available, that's good. Minimum bandwidth is not a requirement. Time sensitivity is not required. If a file is downloaded in 3 seconds or 5 seconds, it's not required. Okay, and the other applications, they are also like this one. Okay, so you can study it in the book as well. Okay, now we comes to know, so as I have discussed to you, say that the application, it interacts with the users. When it gets the data, so it delivers the data to transport layer. Now it is the functionality of transport layer to move the data from one application to another application. So the internet, as I have discussed to you, that these are the requirements. These may be the requirements from application point of view. Okay, but now In practice, in the internet, the transport layer protocol, it provides two type of services. One is called TCP and UDP. These are two protocols available in transport layer. So we now discuss that these services, what they can provide. What services? These TCP and UDP, they are used in transport layer in the current internet. So now we discuss how the TCP and UDP transfer the data from one application to another application. Okay. So the TCP, it has reliability. Reliability means it sends the data reliably. Okay. So we will continue this in the next video. Okay.